Hi, this is lesson 324 on the tangent ratio. So again, this is a continuation of what we've been doing the last few lessons. And um, we're introducing this new term that actually it's not a new topic, just a new term. And so now that we have a trig table of angles and the related slope ratios, let's kind of go back to that original problem that we had with the Leaning Tower of Pisa. Um, in one of the previous videos, I asked you if you thought this tower would topple, and some of you said yes, some of you said no, and so at that point there was really no right or wrong answer. But now that we know a little bit more, let's see if we could uh, come up with a clear answer to this. Maybe some of you will change your mind. So looking at the original picture, let's ask ourselves, what is the slope ratio for the tower? So again, slope ratio is our rise and our run. So we have our rise and our run given to us. So slope ratio, that's just a fraction. So then I'm going to put 50 over 5 is our slope ratio. Um, and this does reduce. All right, so this does reduce to 10 over 1. Now the original question was, what's the angle of slant, or what's the slope angle? That was something that we did not know before. But now we actually have a way to take our slope ratio and figure out what our slope angle is. All right, and that's what our trig table is for. So if you look at your trig table and you look for 10 over 1, what is the slope angle associated with that? Right, so if I jump to that trig table and I look for 10 over 1, so I'm looking on the right side, I'm looking for, there's a 10 over 7, 5 over 1, 10 over 1. So I see a 10 over 1 here at the bottom. And so that is 84 degrees. All right, so if I go back to this problem, so this is going to be, the slope angle is going to be 84 degrees. Now, if you remember from the original problem, it said if the tower is in danger if it falls below, the slope angle falls below 83 degrees. Right, so question is it going to topple? And so for the most part, even though this is really a debate, still debatable, yes or no could be both correct answers. But for the most part, I would probably say no on this one. It's not going to topple. Not going to topple. And I'll just say soon. Right? So it is falling. Obviously, it used to be 90 and went down to 84. It's not far off from 83, but it does still have to go below 83. So it has been over 900 years that it took to fall 6 degrees. So for it to fall another 2 or 3 degrees, it's still going to be a few hundred years. All right. So in that case, it's not in immediate danger. All right. And so moving on, when all the triangles are drawn the same, kind of like we see here, this is kind of like the ideal setup. All our slope triangles have looked something like this. And when they all look like that, it's a little bit easier to determine the slope. It's a little bit easier to look in our trig table. But how can we also make it easier if it's not drawn that way? So does it matter if I take this and maybe if I rotate it, what if I give it to you like this? Would you still know how to find the missing sides or the missing angle? Right. So what we're going to look at is possibly an easy way to solve these problems without having to worry about the way it looks. All right. So here are 3 examples. where they're all drawn a little bit different. And the question is, how can we determine the missing sides or the missing angles if it's not very clear what the slope is? What's the rise and what's the run? So when I look at this first triangle, it looks very similar, kind of looks similar to what we want. It looks like it's rotated a little bit to the right. So maybe you might be able to picture this. You could either rotate the picture or you could rotate, like if I rotate this, you're like, oh, that's fine. I'll just turn it so that it looks like the other ones. That's fine. But what if someone says, no, I want to turn it the other way. I like it standing up like this instead. So does it matter? Does it change our proportions? All right, so what I'm going to do is kind of look at a couple things. One is, what's the angle given to us? And do I have the side information that we need? So the first thing I do notice is I have a 79 degrees given to us, and I have theta, which is the angle we don't have. Now, it is possible we could figure out the missing angle, but I want to try to do this without having to do that extra work, right? I don't want to add more work unless I need to do it. And so as far as setting up a problem for these three, the strategy I'm going to kind of introduce to you is where it involves identifying the angle and then looking across from this so that I could determine what is the side opposite it. All right, so in this case, 12. All right, so I'm using 79 degrees. So then I'm going to set up an equation here where we have, I'm still going to set up a proportion, but I'm going to put the 12 on top and I'm going to put the W on bottom. All right, so as soon as I figure out the angle, I'm just looking across from it to see which side is across from it. All right, so if you remember, the other proportion that we're looking for comes from our trig table of 79 degrees. And so we would have to look up 79 degrees in our trig table. And so if I look up 79, that one is 5/1. All right, so I'm going to go back. And so I'm going to set this up as 5/1. And then we could solve this, cross multiply and solve. And so this would end up being 5W equals to 12, and then W would equal to 12/5. All right, so this is an example of where an actual missing side is not a whole number, right? It actually doesn't go in a nice amount of times. All right, so that would actually be a decimal answer, about 2.4. But the fraction's fine. I don't need the decimal. I could just leave it like a fraction. All right. If I wanted to find the missing angle, then I could use the fact that I know all three angles add up to 180, or that these two angles are complementary, which add up to 90. All right, so that's something we could look at. I'm gonna skip that part. We don't need to know that angle right now because we were able to solve this without figuring it out. So when we look at the second one, now this one is kind of drawn the way we would like it, where we have the rise and the run given to us drawn out. The issue here is we don't know this angle. Right? So we always have to know this angle. In this case, we don't. So, but we do have this other angle here. And so you could solve for the missing angle, but again, I'm trying to avoid us doing more work than we need to. In this case, I'm going to focus on the angle I do have, which is 22 degrees, and then I'm just going to look across. And so that tells me, when I set up a proportion, that Z is going to go on top and then 8 will go on bottom. And so since we are using 22 degrees, I would look in the trig table again for 22 degrees. I still don't have those memorized, and I'm not trying to memorize them because I have a table that's going to give that to us. So 22 degrees is 2 over 5. All right, so I'm going to use 2 over 5 on this one, 2 over 5, and then that's something that could be solved as well. So in this case, I think z ends up equaling to 16 over 5. All right, and then the last one, you'll notice a common mistake on this one is for people to think this is the rise and this is the run, and that's not the case. So keep in mind, look at where the right angle is. So the rise and run always form a right angle. So then I've highlighted this is the rise and this is the run. So I definitely need to focus on where's my angle. And so I'll mark that one. So I'm going to use 18 degrees. So I'm going to draw a line across, and that tells me what goes on top. So when I set up this proportion, I'm going to put x on top, which means, again, this is my rise and run. That means 15 must go on the bottom. And so if I look up 18 degrees in the trig table, I believe that one was 1/3, 1 over 3. So that is something that we could solve. That would be 3x equals to 15. Cross multiplying, in case you don't remember, all we're doing is cross multiplying on these to solve. And so we divide both sides by 3, and then x is equal to 5. All right, so this would be an example of a test question you might get. Here's a triangle, tell me what the missing side is. And you'll set up a proportion and solve. All right, so even though it's nice to have our trig table, again, this is the trig table we've seen before, and we're pretty much pulling all our answers, there's still an issue here. If you haven't noticed, there's a lot of angles missing, right? These are not all the angles possible. Like where's 71 degrees, where's 80, etc. So this table's still missing some. Because of that, we need some other strategies or tools. All right, so in summary, here's kind of, in case that was a little too fast for you, here's some notes on how to set up your problem. So the method to set up the problems for when the triangles are rotated or reflected is first, like I said, always look to see what angle you're focused on. And so it doesn't matter where it's located, if it's at the top or the bottom, as long as it's not the right angle, you'll never focus on the right angle. So wherever the angle is that they give you, then you're going to draw a line across from it, and this is what we call opposite of the angle. All right, so this is the side opposite of the angle. That's what we want. So the side directly opposite is always going to be your delta y, is always going to be your rise. The side right next to the angle is what we call adjacent. All right, so it's adjacent to the angle, which means right next to. It's touching. So the side and the angle are touching versus the opposite one is not touching the angle, right? It's across from it. All right, so you need to know which angle you're focused on. You need to know where the opposite angle is. That's the second step. And then the third would be to make sure you know where the adjacent side is. So this other side here is what we call the hypotenuse. Hypotenuse. All right, so that's something that we'll look at a little bit later. But for now, we're focused on the opposite side and the adjacent side. All right, so if you're given a problem like this, again, this is kind of like a test question you might get. What's the missing side length? So you could see it's been rotated. So you could either rotate your head, try to rotate the drawing, or you could just focus on the steps that I identified earlier. All right, so I'm trying to avoid doing more work than I have to. So the first thing I would probably do is say, okay, I have 18 degrees, and I'm going to draw a line across from it, and this means this is going to be my delta y, which means the other side, which means this other side is going to be my delta x. All right, so rise over run is the same as y over x. So when I set up my equation, my proportion, I'm going to put 4 over a. And then 18 degrees, if we look that up, we just finished doing that. That was 1 over 3. And again, cross multiplying these like we normally do, we'll end up with a is equal to 12. And we found the missing measurement. All right, and that's pretty much it. The hardest part is setting it up. The hardest part is figuring out which number goes on top here. So if you know the one that goes on top, then only the other leg would go on the bottom. All right, so that's kind of what we need to do. So like I mentioned earlier, this is nice when we have the proportions given to us. The ratios given to us in our trig table, but there's a lot missing. All right, so in order to deal with that issue, what's nice is we have calculators that will give us all the ratios we need. All right, so and I'm going to go over a few examples on this. I think I'll stop there. So since our trig table doesn't have every possible angle, we can use a scientific calculator or maybe a graphing calculator, which also has scientific features as well, to give us the ratios we need. The only reason why we needed the trig table was to get those ratios, or to use the ratios to get our angles. So the slope triangles we have been using will give us the slope ratios, and that's what we've been looking for in the table. But those actually go by a different name, another trigonometric name, right? Because we're studying triangles, trigonometry. This is called a tangent ratio. Right? So a tangent ratio is really the new term that you need to know. So instead of using slope ratio, we can use the term tangent ratio. All right, so all the tangent ratios, right, slope ratios, tangent ratios, are in the calculator, so we don't need our trig table. All right, so some of us may or may not have a physical calculator like a Texas Instruments or a Casio or some brand like that, but most of you, all of you should have a calculator near you, either on your phone or on the internet. There's a few handy for us. So if you happen to I have an iPhone, so I took a picture of that so you can see that. All your calculators, even non-iPhones, have scientific calculators as well. So in this case, if you didn't already know, if you rotate your phone, it will give you the scientific calculator, which gives us a lot more features. And so what we're really looking for here, and here's a Google calculator as well. I just went to Google, I typed in Google calculator in the search, and it takes you to a calculator, which I think a lot of you have already used as well. And so you'll notice some extra features as well. So what we want to use is this button called tan, which, in case it's not too obvious, tan is short for tangent. Right? So tangent ratio can be found using the tan button. So that's going to give us what we need. So if you had an iPhone calculator, you should notice there's a tan button as well. So that's there for you. If you're using a Google calculator, you'll notice there's a tan button as well. That'll give you all your tangent ratios. If you go to desmos.com and they have a scientific calculator, not their graphing calculator, their scientific calculator. It looks something like this, and again, they have a tan button as well. I even added an extra one. If you just went to calculator.net, I think they give a pretty simple and cool looking calculator. This one also has a tan button as well. All right, let me back up a little bit. So scientific calculators have this button for us to access our ratios. So we want to kind of see if this is true or not. Does it work? What does it give us? So here's an example. Here's a triangle. We already have all the measurements. But if you didn't notice, these are actual numbers or angles that are not in our trig table. So these are something we cannot look up in our notes. We would have to use the calculator at this point. So let's type these in the calculator to see how close both ratios equal each other. All right, so I've set these up for us already. And so when we go to a calculator, the question, you can't just press the tan button and it's not going to know what to give you. You have to tell it. And so when you press the tan button, if I press the tan button, what it's going to do is it's going to put tan, and usually it's going to put some parentheses for you. Or at least it's just going to put the first parentheses because it's waiting for an angle. It's saying, okay, go ahead and give me an angle and I will tell you what the ratio is. So if you type in 32, and then I like to put another close parentheses, and then I hit equal, then it will give us an answer. All right, and what I want to know is, if I type that into a calculator, does it equal to the same thing as the actual rise and run? All right, so 32, across from 32 is 5, and the run would be 8. All right, so that's why I have 5/8. So instead of me looking up in a trig table, I'm writing it like this: tan 32, tangent of 32 is equal to 5/8. Well, let's see. Let's double check that. So when I type this into the calculator, I've actually used two different calculators just to show you that they both work. So I type in tan of 32. I hit the button tan and then 32, and I think put in another parentheses. And when we hit enter or equal, I think the button's equal, it gives us this decimal. So 0.62486935519. When I type in, I use the Desmos. I think this is the Desmos calculator, and because I like the way it shows the fractions, I typed in 5 divided by 8, 5 divided by 8, that gives us our fraction, and you'll notice it gives us 0.625. So 0.625. So you'll notice that's pretty close to this decimal. If I round, then that means this is going to turn into 0.625. All right, so are they the same? Right, so this was 0.6248. This is approximately, and then this one was 0.625. So those are pretty close, right? So those are pretty close. So close enough where you would say, yeah, those are the same. And so if we try the same thing with tangent of 58 degrees, what you'll notice, these are complementary. They add up to 90, and you'll notice the fractions are reciprocals of each other as well. So if I type that into a calculator, tangent of 58, I think I have that somewhere. All right, so on this one I use the Google calculator on both of these. And so we have tangent of 58 is 1.6000 with a bunch of numbers. And I did 8 divided by 5, and it gives me 1.6. So you'll notice they both give us pretty much the same answer. All right, so 1.6 is pretty much, this one was approximately 1.6, and this one was equal to 1.6. Right, so I would say that's pretty close as well. All right, so that means that calculator is giving us the exact ratios that we need. So now we don't need to use our trig table. We could just use our calculator. All right, so let me try to wrap this up. This is the last problem. And so now that we know how to use our calculator, I want to show you kind of how you would do this using tangent and how to set up your equation properly. So the way I'm going to do these is pretty much how I would expect you to do them when you're showing your work, or at least even if I'm not looking at your work, you should probably be doing it like this, because it's going to make your answers a little bit more accurate, fewer mistakes. All right, so on this first triangle, I've already highlighted the angle that I'm working with, 38 degrees. And so I'm going to do what I normally do. I'm going to draw a line that goes across. I like to highlight that line just to make sure I know which one's opposite. All right, so this one's going to be opposite, which means this other one's going to be adjacent. So when I set up my equation, I'm going to put tangent of 38 is equal to, and I'm going to put x over 8. All right, so this is what I'm looking for. This is how you should be setting up your problem. You'll notice before we used to have a fraction equal to a fraction. Now instead, we're going to be looking at kind of a new type of fraction. Now it doesn't look like it, but we could turn this into a fraction. Let me move this down. So I'm going to actually put this all over 1. All right. So now it looks like a fraction over a fraction equal to a fraction, which is our proportion that we've been looking for. All right. So now let's solve this. We're still not even using the calculator, and really we don't even need to use the calculator till we actually want a decimal answer. So usually what I tell students at this point is, if you are already reaching for your calculator and typing that in, you're doing something wrong. All right, so the calculator is not going to instantly give us our answers. That's just going to help us finalize our answers. So be careful when you solve these. So what I'm going to do to solve this, we're going to cross multiply like we normally do. Cross multiply like we normally do. And so that's going to, x times 1 is x, and 8 times tangent of 38. So I'm going to write it like this: 8 times tangent of 38. All right. So you'll notice I'm still kind of keeping the parentheses there. I want to make sure I'm not confusing it with any other numbers. These go together. In case you're not clear, these will always be stuck together until it's put into a calculator. And so if I was typing this in a calculator, I would actually type in this whole thing. So what I'm going to introduce to you now is really this idea of, here's an exact answer. So we'd be done, right? There's nothing more to do. So this is us not even using a calculator. We don't need to know more. This is an exact answer. If I wanted to know an answer, I would just type it in the calculator. So if we did we already know I'm going to have some decimals. And so usually at this point, I change this equal sign to a squiggly equal sign, which means approximated. And then I could type that into the calculator. And this is going to give us approximately 6.25. And this would be an approximated answer. All right, so this is kind of what's expected of you. Set it up, solve for an exact answer, and then solve for an approximated answer. Some test questions might only expect you to do an exact answer, which means it's even easier. You don't even really need a calculator for that one. The harder ones would expect a decimal answer where you need to make sure you're typing it in correctly. And all right, I'm going to quickly try to do the remaining two on these. Let me kind of shrink this. And all right, so I'm going to go through these a little bit faster, maybe just show you the work because I know this video is getting a little bit long. So I have 73 degrees. I'm going to go across, which means the 9 is going to go on top. All right, so that means I'm going to have tangent of 73 is equal to 9 over x. And so again, if I make this a fraction as well, and we cross multiply, I'm going to have x times tangent of 73 equals to 9. So this one's a little bit different. This is the one that usually people will make mistakes on. You'll notice the x is actually on the bottom this time, not like the previous problem where x was on top. And so because it's on the bottom, we end up with the x being multiplied to the tangent. And so that means we need to do an extra step. So I need to get x by itself, and that extra step means I need to get rid of the tangent from both sides. So I'm going to divide both sides by tangent. All right, and so when I do, you should notice these will reduce. They will equal to 1, and I'm left with the answer of x equals to 9 over tangent of 73. And that would be my exact answer. All right, which is fine. You don't have to do anything with it. I know some people don't like fractions as answers, but that's pretty much it. That's the extent of the work. If you type that into a calculator and you solve that, you would have to do 9 divided by tangent of 73, and that would give you approximately 2.75. All right, so this would be an approximated. So 2 possible answers depending on what the question is asking. And in this one, we've actually have seen a 45 degree angle in our trig table, but it still works the same. We'll do tangent of 45 is equal to, again, this is going to be x goes on top. Oops. X goes on top over 14. If I pretend this is over 1, and then when we cross multiply this, this is going to be 14 times tangent of 45. All right, and then that would be our exact answer. And then approximated would actually equal to 14. Right? It is exactly 14, but it's still, we could still call it an approximated. All right. So this is pretty much the type of problems you need to be able to do. Um, these are definitely problems you should have in your notes because you will see similar problems to this as well. All right. I believe that's it for these notes. Let me know if you have questions. Definitely, this is one of the major portions of this chapter, so you want to make sure you understand it. Alrighty.